Hello everyone, I'm going to do one last video just to show you things. I wasn't really thrilled with how I finished up with templating. Why? Because I took what we originally were working on throughout the term and was adding more and more and more. And at some point in time, the critical mass of trying to figure out how all of these parts work together, I thought was obscuring what I was trying to actually show. So I wanted to show you, here's the very simple version of it. That should do it. Okay. So here is code for a linked list, absolutely as stripped down as I could. There's a couple of extra little parts in there just for testing purposes, but effectively it's the stripped down version of a linked list. So I have a linked list that I can create a new linked list, destroy my linked list, so a constructor and a destructor. I didn't even put comments on this thing just because I just cranked it out quickly. I can add an element to my linked list. I'm adding linked list data elements. It could be an integer, it could be a string, it could be whatever I want it to be. For the time being, at least, this is the requirement that I have. I am inserting these data objects called linked list data objects, right? Some kind of data. We'll look at that, what they are in a second. I can get the size of my linked list because, useful. I might want to have at the end of my linked list, something like that if I want to do that. I can get the individual, no, it's a linked list, so I don't want to have that. I want to have like how many elements I have. I want to be able to get a particular element at a particular index. Why not? I could have just get the front potentially if I wanted to do that instead. Or get the tail. That would also be perfectly reasonable things to get. I chose to get a particular index. Underlying all of this, though, is this data structure that is storing a bunch of information one after the other in this chain, right? So one node connects to the next node, which connects to the next node, which connects to the next node. And I happen to allow you to get based on a particular index. So effectively, if I took all of this linked list away and put in an array instead and just had the same function calls, everything works the same, right? I could have implemented this without a linked list, calling it linked list, pretending it's a linked list, and actually just made an array. Or I could have used some other data structure. The point, in case you're wondering what my point is, the point is by hiding all this information, by insulating everything, you don't need to know how this entire data structure is implemented. I happen to be using a linked list. I called it a linked list, but I could have called it Susan and filled it in with some other stuff. Someone does not need to know how it's implemented. In fact, if you notice here, at no point in time do I ever say the word LinkedList Node in any of the public functions that I have on purpose, because you shouldn't have to know that it's using a whole bunch of these linked list nodes one after the other. You just have some data structure and it returns data. I want a big black box that stores stuff, and I pull out stuff, I put stuff in. I want it to just be unknown, so I can use it as a tool in case you're wondering why. Okay, here is some private functions. I can get the previous, I can get the next. Great. I think I'm using those. I'm not sure if I am, but I have it as some functions, and I can get the last node as well. So what I should be able to do with linked list node is I should be able to keep on getting the next, calling get next each time, and just walking down my linked list until I find out that the next is equal to the last, and then stop. Okay. That is what my header file looks like. This is my CPP file. So here I am. I have a head and a tail to my linked list. Those are private, by the way. And they're starting off at null. And then I'm just going to walk down when I'm deleting my linked list, I say the current is equal to the head. I get the next element. I delete the current. I get the next element. I delete the current. And I just keep on walking down my linked list. Oh, and since I'm deleting things, I'm going to shift my head. So the head is equal to the next element in my linked list, and I delete the old value. And just keep on doing this until I'm at the end, and then I stop. So while the current is not equal to 0, that's the same as saying while p current not equal to null, same thing. Okay. And then at the end, once I've deleted all my nodes, I just set the tail equal to null, and I'm done. Here is me printing off. I have a print list function, and I'm just going to output, go down each one of my nodes, get each node, and I'm going to call, here we go, the toString method on my current node. And that's something important that we're going to see again and again. So it's going to call toString. It's going to take this node, convert it to a, get a string from that current node. And we'll see why that's important in a second. Here's me adding it. I'm going to add it to the list by going to the very last element of my, so if the head is equal to null, then I set the head and the tail equal to this new node. Otherwise, I add a node to the tail and then update the head, update the tail. So I stick the node at the end. I can get the size by just getting it, having a number, and walking down my linked list until I get to the end, and then returning the number of nodes I found. I get the individual index by counting until I get to the number I'm looking for, stopping and returning that data. Okay, all of this should be well and good. I can get the last element, I get the next element, right? Here's linked list data. So let's linked list data. I can get a value, or I can set a value in my linked list node. I can get the particular value from my linked list node. I'm a little surprised by that get the value and set value thing here. Okay, I can, oh, that's because I'm going to template it later. Okay, and I can get a string representation of this thing. And all that's going to do is take whatever value I have in there, convert it to a string to represent it, and spit that out. So if I run this thing, I should be able to just run it, and hopefully it's going to work. There we go. I am adding, and so I have this tester method. All I'm doing is I'm adding 20 elements to my linked list and each one of those, each piece of data just stores a number. That's all it's doing. It's storing a bunch of integers. And why am I doing this with all of this extra code? Because there's a certain amount of infrastructure I need to store this thing. So I'm wrapping up a number in this data, this LL data object. All it's doing is holding a number. Then each one of those things is added to each of my nodes, and each node points to the next node as well in this chain. Okay. The point of all of this. So if you were just trying to figure out how linked lists work, that would be probably a good place to stop. So if I have my tester code, I make a linked list. I keep on adding a number to my linked list. So I'll make a linked list data object, add it to my linked list, and then I print off my linked list. And at the end of the day, when everything gets destroyed, and notice it automatically gets destroyed because I'm not calling new on my linked list. I'm just making a local variable called linked list. I will automatically call my destructor when the main method is finished, and I got all those destructor calls. When I'm doing my linked list and I'm adding something to my linked list, where's my add? There's my add. I am calling new for each linked list node. And so when I'm done, my destructor goes around and destroys all of the linked list nodes afterwards. Here we go, delete each of the current nodes. And so when I'm done with my linked list, I automatically clean everything up. Here's linked list data. I should only need to show you the header file. I have a constructor, two different kinds, one for blank one, just because I want to set a default value. So here is my overloading. The function is overloaded, the constructor is overloaded. I have two different ways of calling that constructor, one with a value, one without a value. I can get the value here, I can set the value, and I can convert it to a string. That's the big one. Actually, I think all three are technically necessary, but because we're going to see this again. So this is a linked list. Now I'm going to do the cooking show version of this and just say, I have already templated out this entire thing. Everything I had before, and both versions of the code are available to you. So here we go. Simple template starter. This is the one that I just showed you. Here is the templated version of that code. Okay. And this should be it. Okay. Notice, by the way, I have this new thing that I didn't have before. We'll ignore that for now. I have LinkedListData.cpp and LinkedListData.h. I got rid of all my other CPP files. What? And my tester is still around. All right, so let's look at my tester. I have a linked list data, and I'm storing inside of it, I'm storing one of these linked list data items. That is the kind of data being stored. I have to tell them, when I have a templated class, I have to say what kind of data is being stored each and every time. I then can add, this is just a comment, right? So I can add a link, make a linked list data object, and add it to my linked list, and I print everything out. In fact, if I run this again, you should see no difference to what I had before. It's building, I didn't build before. Boom, there you go. Exactly what I had before. And yet everything's different. So it looks exactly the same. It acts exactly the same, except it doesn't need to take in just linked list data objects. So let's look at this. First thing, I got rid of all this CPP/header file thing, and I put everything in a header file. And you're probably wondering, why don't you do that all the time? And the answer is, it's a pain in the ass. I don't want to do this unless I absolutely have to. So normally I design my code correctly, and then I migrate it over to being a templated class. Because let's have a look at what this thing looks like. So everything is in the header file. I include this thing up here, which is saying it's going to be a templated class, and the template type is T. I don't know what it's called, right? We don't have a name for it. We just put a T, right? Something, foo, right? The thingy thing. It's a templated class. It's something that you don't have an exact name for. You will figure out the name later. So everywhere I have a T, it means I will come up with that later. So what kind of data is it? It's, the data T thingy thing, right? So it is a linked list, so it is a templated linked list class. And you'll notice when I get down here, every time I use a linked list node, I have to say, by the way, it's a linked list node of type T. Even the pointer is type T. It's just sort of good habit to get into. So I will get the head, and I will say, okay, this current is a linked list node that stores a T. Because later on, when we use this thing, we will have to make we will essentially make a brand new version of linked list node that stores one type. And then we'll make a brand new linked list node that stores a different type. And we will actually be generating classes on us. So this says it's storing some kind of data of type T in a linked list node. When I add something, I will add data of type T. Notice we had it was LL data when I called add. But in this particular case, right, in my tester, I just called add, and I put a linked list data type in. But I'm not saying what kind of data it is. I'm just saying it's data type T. I don't know what kind of data type it is. I will make a brand new linked list node of type T, and then I will add it. But the code is essentially the same. It is literally copied and pasted from the previous version. I just then had to modify everything. When I want to get the size, I get the current head, and it's a linked list node of type T. Everywhere I have a particular kind of data, of templated data, I need to put that in there. Linked list node of type T. Linked list node of type T for print list. It's the exact same code, except for instead of just saying linked list node, I have to say it's a templated linked list node. Same thing here. Get previous, get next, get last. Here are my variables. They're not just linked list nodes. They're linked list nodes of type T. Here is my linked list class. It again is a templated class. Great. It will store, it has a next, it has a previous. Here's my constructor. It takes in some kind of data of type T. If I wanted to copy, this is the data I'm going to be storing in my linked list node. Here's my destructor. I don't have to do anything special in this. I have a toString function, and there is the big one for me. I think I already did change it actually. That's this is a note for myself. So if you go to, let's flip back for 2 seconds actually. Oh, that's the other one. And LinkedList data, LinkedList Node.h, LinkedList Node.cpp, and there we go. It was changed. Good. Originally, I didn't have that. Originally, I had me doing a bunch of other stuff. So I converted it back. Why? Because this is just going to get the data that I have, and it calls this function called toString. And you're probably wondering why if this whole linked list data structure, if I have get value and I get an integer, why do I have this toString function? What's the point of having this thing here? And the reason is that I don't want to know how this thing works. I just want to call toString on whatever my data type is and have it print something out properly to the screen, or at least store it as a string that I then can call cout on. And that's sort of the point. Your data itself has to have certain requirements. You have a certain contract for what your data that you put in there has to be able to do. It has to have some kind of function called toString, and if it doesn't, if you try and put that kind of data in your linked list, it goes, no, you can't do it. LinkedList Node says there's a function called toString for your data, and if you don't have it, blow up. I can actually show you that in action. So okay, so I'm going to be calling this function called toString, and no matter what, for whatever data I store in there, and if my data does not have that function, I cannot put that data in there. When I try and put values in a vector, and I don't have the comparison operator, I put it into any kind of data structure, and I don't have the comparison operator, I can't call the sorting functions. It has to implement that particular operator. If I say that this thing has a function called toString, if you give me a class that does not have a toString function, it will not let me put that in my this particular linked list. I'm not sure if I need the get next, set next, all that kind of value, all those other values. Let's see. Do I need anything else? It's just a copy constructor. No, actually, I don't think I even need the set and get methods. I needed toString. That's all I needed in this particular case. Okay. So if I want to add, so let me see here. LinkedList Node, get next. Here is me adding the next element to my list. This is me just providing some kind of class that I think this is meant to be a, I think this was actually in the original one as well. So I will figure out where this thing is going to go. I have the node that is going after this thing. If I'm inserting this node, I'm going to add this node after whatever my current node is. So if I already had a bunch of stuff afterwards, then I need to do some shifting around. This is me working around this. I call add next to the whatever it's at. So I'm inserting this node here after the current node I'm in. And if there was already stuff behind it, I need to then add this stuff behind it to this value here. So I'm inserting this node in between these two parts. I could put asserts, I could do a bunch of other things, but this is one way of doing it. Okay. That's not anything to do with this whole templating thing. So here we go. I have a template. It takes of type T. And so if this data type is anything different than the current one I'm in, it won't let me do it. They have to match. It's like putting X in as a variable, right? If I put X in a math equation, every time I see the word X, it's the same X. It's not a bunch of different X's. It's the same X. Okay, so let's go down here. I have my next, which is of type T, and a data of type T. If I went back to the other one, let's see if I can do that. If I go back to the other one, LinkedList Node.h, here it is, LinkedList Node, my next, and here's my data. In my new version of it, here's my node with a T, here's my data. Let's compile it again. And I just removed a comment, by the way. That's all I did. Here's my linked list data. And that, by the way, has not changed at all. At all. Here's the thing. Here's me doing my tester. And I'm saying I'm putting in linked list data and everything works as expected. Now let's change it. So instead of linked list data, I have a brand new class that we didn't talk about yet called LinkedListStringData. It stores a string. I know, very original name. I can set values, I can get values, same as I did before, and the set and get functions look exactly the same, but instead of having an int and an int, it's a string each time. My constructor takes in a string instead of an int. It is of type, T, whatever I'm storing in this thing. Okay. And so here, and I'm keeping this kind of text around. Okay. So LinkedListStringData doesn't do really anything different than the original one, other than it's dealing with strings instead of integers. That's it. That's the only difference between the two. But you would not be able to do this otherwise. So LinkedListStringData, and I'm going to put this in here just because it's a lot easier to deal with that. And instead of I, it's to add, just because I want to have text and then some number. This doesn't work because it has to be string data. Compile it. Run it. Get the same sort of thing. I'm storing completely different variables. I'm storing a bunch of strings in my linked list now versus a bunch of integers now. Hey, let's go one step further and let's do this. And I'm going to ll2.add and ll data and if I wanted to do this, and ll2.printlist. Right, so I've made two linked lists. I've added a number in one. I've done this printout in the other one, and it should be the same thing. So now I have two. This is not the same linked list. I have two completely different classes. You don't have to see those classes, but the compiler sees two completely different classes called linked list, string, linked list. It would actually have some random number, but I have two different versions of linked lists. One that stores string data, one that stores integers. And you're unaware of it. You're just pretending that it's a linked list. It's the same linked list for both of them, but they are actually different. It's generating classes for me. But by having sort of a templated form, I can throw whatever I want in these data structures. So if I run it, hopefully we'll see it work in action. There you go. Here is the linked list 1. Here is linked list 2. Here's me deleting the first linked list. Here's me deleting the second linked list. And because it's a template, I don't have to re-implement linked lists with integers and re-implement linked lists with strings and re-implement linked lists with this and re-implement linked lists with that. Let's do one last thing. Let's be a pain in the bum. And toString, I'm just gonna comment this stuff out. I really should learn the hotkeys for. There's a hotkey for just commenting out a block of code. I always forget what it is. Okay. And I can't call this function. Right? This is linked list node. It worked perfectly fine. It says I have a particular kind of data coming in, and then it says data does not have some kind of function called toString, and I get a compile error. I cannot, until I implement some function called toString in this child class, or in the class that's storing the data, it will not let it compile. That's how templating works. It checks to see if you have the requirements for being able to be put in this linked list based on the templating. And if you're not allowed to do this, blow up, give you a compile error. So those are really hard to track down, but this is the reason why we're looking at this. because it's extremely useful not have to reinvent the wheel each time. I don't want to have to write linked list 40,000 times, right? I want to write it once. I want to write it correctly and then be able to store different types of data in there. And that's what a templated class gives you. Okay. So let's put that back in. Let's put that back. There's a hotkey, but I really, yeah. There we go. And we're back. All right. So that is templating. That's a simplified example. I'm hoping it's a bit more clear than the last example I gave you in case you wanted more of a streamlined format for this. We did the same thing with the other more complicated version of linked list. It just was more complicated. So hopefully this is a bit more obvious of what I'm actually trying to accomplish here. Okay. Thank you very much, everyone, and I'll talk to you guys later. Thanks.